So this video is going to go over kind of the extra factoring methods that we learned in this topic. So this was in lesson 1 if you look at your work from there. But this is just going to be an example of each new type of method. The first one is when we have to take a GCF out, which should always be your first step with factoring, is looking for that GCF. The second example is going to be when there's 4 terms that you're dealing with. And the last example is going to be when there's an x to the 4th term. So if you want to fast forward, skip ahead to a different part of the video to see one of those, feel free to do that. But first, what you should always look for every time to start is a GCF. Is there something that you can divide out of everything? So when you do that, you're looking at the numbers and you're looking at the variables. So first with the numbers, we're dealing with, I have 9, 45, and 3 here. And I'm just looking at, is there something that they all have in common? And yes, there is. They are all divisible by 3. So what that means is we're going to take a 3 out, and we're going to divide it out of each of them. Now we look at the variables. We have x to the 4th, x cubed, and x to the squared. So they all have an x in them. And then beyond that, they all have at least 2 x's in them, because x to the squared is the smallest one. So that means we can take out a 3x squared. Once we find out what that GCF is, now we just divide it out of everything. So 9 divided by 3 is 3. X to the 4th divided by x squared is x squared. You just subtract exponents when you're dealing with those. And 45 divided by 3 is 15. X cubed divided by x squared is just x. And then negative 3x squared divided by positive 3x squared leaves us with a minus 1. And even if that was a plus and we were taking out the full term, you would still have to have a plus 1 in there as kind of a placeholder. So we have it factored. Last step, we want to make sure it can't be factored further. A lot of times there's 2 steps in these. So to check that, you're looking at your piece that you had left to see if it can be factored further. We can draw a quick box. Remember, you multiply on the diagonal, so we have negative 3x squared. The only factors of 3 are 1 and 3. There is no way for 1 plus 3 to equal 15, so that means it is indeed fully factored, and this would be our factored answer. So that's always, every time, you should look for that GCF first. The next kind that we dealt with was when we had 4 terms. And these are actually easier than the original type of factoring you learned because you don't have to figure out what goes in the box. All your terms are there. So we have 1, 2, 3, 4 terms. We have 4 spots in our box. So we put our x cubed in, our 12, and it really does not matter the order that these second ones go in. Okay, so from here we can take, as long as we get GCF out of 1 column or row, the rest of it we can use logic and problem solve our way through. So I'll start with this row. We have an x cubed and an x squared. So the GCF there would be an x squared. And now we can kind of problem solve our way through. So in order to get x cubed, x squared will have to be multiplied with an x. In order to get negative 3x squared, it'll have to be multiplied by negative 3. And in order to get negative 4x, x will have to be multiplied by negative 4. So this gives us the factoring x squared minus 4 and x minus 3. And again, don't forget to check to see if it can factor further. This one can with that x squared minus 4. So this one should be x. And that's a difference of 2 squares. So it turns into x plus 2 and x minus 2. And then you still have that x minus 3 on the end. So there's that one fully factored. Okay, last one was when we had an x to the 4th. We can still use the same methods we do for normal quadratics here. We just end up with an x squared in our terms. So we can still make our box, put our x to the 4th, first term in the upper left, last term in the bottom right. To figure out how to fill in the rest of the box, we multiply those. So we need 2 numbers that multiply to 900x to the 4th and add to negative 61. So there's tons of factors of 900. We can start listing them. 9 and 100, 2 and 450, so forth. This is when I would highly recommend having Desmos out and just typing in 900 divided by 3, divided by 4, divided by 5, so forth, because we will end up finding our factors here at 25 and 36. It's a negative 61, so that means it'll be negative 25, negative 36. And since that middle term has the x squared on it, x squareds go on those as well. The rest of this works as usual. Look for one of those GCFs so we can pull an x squared out of both of those. Negative 25, negative 36. So this factors x squared minus 36, x squared minus 25. And again, you want to look to see if those can go any further. These are both differences of two squares. The square root of 36 is 6, and the square root of 25 is 5. So those were those new factoring methods that we touched on during this unit.